Assalamualaikum and good morning. My name is Reda Arif bin Kalushari and I want to introduce about history of anemometer. Anemometer are devices that can measure wind speed. They are a vital part of weather monitoring and forecasting. The first known description of an anemometer was given by Leon Battista Albert in 1450. In 1635 to 1703, Robert Hooke developed his own version with some being mistakenly credited as the inventor. In 1846, John Thomas Romney Robinson improved upon the design by using 4 hemispherical cups and mechanical wheels. Then, in 1926, Canadian meteorologist John Peterson developed a 3-cup anemometer, which was improved by Brevoort and Joyner in 1935. In 1991, Derek Weston added the ability to measure wind direction. And lastly, in 1994, Andreas Flich developed the sonic anemometer.
My name is Muhammad Nur Hadi bin Yusuf Khalid. I will explain about the working principle. In the constant current method, the anemometer is placed in the stream of the fluid whose flow rate needs to be measured. The current of constant magnitude is passed through the wire. The Wheatstone bridge is also kept on the constant voltage. When the wire is kept on the stream of liquid, in that case, the heat is transferred from the wire to the fluid. The heat is directly proportional to the resistance of the wire. If the heat reduced, that means the resistance of the wire also reduced. The Wheatstone bridge measures the variation in resistance, which is equal to the flow rate of the liquid. For constant temperature, the wire is heated by the electric current. The hot wire, when placed in this fluid stream, the heat transfer from wire to the fluid. Thus, the temperature of the wire change will also change the resistance. It works on the principle that the temperature of the wire remains constant. The total current required to bring the wire in the initial condition is equal to the flow rate of the gas.
And good morning, my name is Faika binti Fazhani. Today I would like to share about advantages of thermal anemometer. Firstly, it's mainly used to measure speed, pressure and direction of the wind. Secondly, it consumes less power according to its cost and provides precision during the measurement. Next, it is available in different sizes and shapes. Thirdly, high sensitivity and fast response. And lastly, this climate station device can detect, estimate and provide all information related to wind.
Warahmatullahi wabarakatuh, and very good day to everyone and to my lecturer Mr. Azizul, and welcome to my presentation. Okay, first of all, let me introduce myself. My name is Muhammad Ismail bin Muhammad Yusuf, and as you can hear what's in my friend explanation and description about the advantage of the thermal anemometer. Okay, today I would like to give you an overview of what is the title of the disadvantage of the thermal anemometer. Okay, firstly in my presentation I will focus on 4 main parts. It's my first part that concern is the main drawbacks is the anemometer may get a damage due to the strong winds and can result in insufficient or even the opposite pressurization. Okay, however, the distortion may occur in the thermometer due to the strong wind. And next I will focus on the second point of the disadvantage of thermal anemometer. And the point is the anemometer will easily affected by the ambient temperature, and its temperature drift is one of the most important source error. It is also expensive and costly for using and for maintenance the thermal anemometer. And then I will go to the highlight what I see the main point of disadvantage of anemometer is the high turbulence intensity. It is restricted to low and moderate turbulence intensity flow. However, the flow disturbance from the outside the measurement plane alter the results. And next, this leads directly to my next point is the liquid flow. It can contaminate to the probe more easily, and the temperature change in the fluid affected the result more to the smaller overhead ratio which used in liquid. Okay, lastly is the signal noise. It will also affected, for the example, is the secondary noise. And finally, what is the main point from the thermal anemometer disadvantage is I would like to address the problem of anemometer. That is the transfer and aerodynamic problem. If these probes are not sensitive to flow the direction reverse flow. Furthermore, the probe support interface with the flow onto the other sensor, which is a multi-component probe, and second is multi-probe arrangement, such as for the space correlation measurement. And that's all from me about the thermal anemometer disadvantage, and I hope it will describe about the thermal anemometer advantage. That's all from me. Thank you. Assalamualaikum.
Assalamualaikum. My name is Anisha Fika and I will talk about application of thermal anemometer. They will have 5 points. The first is automotive industry. It is for monitoring the air intake of the engine. The second is chemical industry. We all know that the ammonia gas is for measured in chemical fertilizer plants. The third is pharmaceutical laboratory environments. It is for monitoring airflow in biosafety cabinets, chemical fume hoods, and laminar flow hoods. The fourth is metallurgy industry. It is for measurements and control of heating furnace gas. The last point is power industry. It is for hydrogen measurements. Thank you.